5th November 2013. The Mars Orbiter mission takes off from Sriharikota, making India the first country in the world to reach the red planet on the first try. 3 years later, on 15th February 2017, India sets another record by launching the most number of satellites on a single rocket, 104 in one go. India also launched and recovered a crew capsule for its future Mangalyaan manned space mission. And how did India manage to achieve all these space records? The French helped them. Wait, what? Yes, the country famous for its pines, baguettes and the Eiffel Tower is the secret behind India's space success. Okay, that's way oversimplified. Let me explain. You see, Indian Space Research Organization has a rocket called the PSLV, short for Polar Satellite Launch Vehicle. And powering the second stage of this rocket is the engine called Vikas. The Vikas engine is one of the most powerful liquid-fueled engine ISRO has. Not only is it powerful for what ISRO needs it to do, but it's also highly reliable. So reliable in fact that when ISRO was building the new GSLV, it used 4 of these Vikas engines for the strap-ons alongside the first stage. But what about the French connection? Yes, I'm getting to it. You see, the Vikas engine is based off the French Viking design from the 1970s. And all the success has got to do with how India managed to get its hands on a Western rocket engine design. You see, France had been rather pally with India, having supplied fighters for its air force. So the two countries collaborated for rockets and an MOU was signed in 1964 between the French CNES and India's Department of Atomic Energy. Remember, ISRO only came into existence in 1969. The French helped Indians with solid propellant rockets and the first Indian-built Centaur rocket was launched in 1969. Dabbling with these, Indians mastered the solid rocket fuels. So it doesn't come as a surprise that India's first rocket capable of putting a satellite in orbit was a 4-stage vehicle with all solid propellant motors. Liquid fuel tech was put on the back burner. Then someone probably at ISRO realized, hey, liquid fueled rockets are actually a good idea. You know what else is a good idea? Subscribing to the channel and liking this video. In 1974, the two countries went back to the table and another contract was signed. This time between ISRO and SEP, the European Propulsion Company, but this MOU didn't involve any money. What was exchanged was Indian intellect and hard work for French technology. SEP would provide ISRO transfer of technology of its under development at the time Viking engine in return for 100 man-years of ISRO engineers working on the Aryan launch vehicle development. Over a course of 5 years, 40 ISRO brains learned everything there was to learn about the Viking. Indians were involved in all stages of the engine's development and participated in progress reviews and received detailed design and documentation. The acquisition of the Viking engine technology was so far-reaching that it affected the design of the first Indian rocket that was to use it, the PSLV. The Viking was not a very complicated engine, relatively speaking of course. It used hypergolic propellants, dinitrogen tetroxide and unsymmetrical dimethyl hydrazine that ignite after coming in contact with each other. Back home in India, the Viking was renamed Vikas, meaning progress, and also a portmanteau for the initials of Vikram Sarabhai. And just like the Viking, the Vikas engine has been a reliable workhorse for India. India continues to use and improve the Vikas engine while the French have now retired the Viking. At least 5 different versions of the Vikas engine are known to exist, with a nozzle diameter ranging between 1 meter to 1.8 meters and a thrust ranging between 600 kN to 800 kN. The latest variant is called the high thrust Vikas engine and it is being used in ISRO's most powerful rocket to date, the GSLV Mark III. 2 of these high thrust Vikas engines form the core stage of the rocket called the L110. Here too, it has flown without any niggles in the 3 developmental and 1 operational flight. But with the space station and manned missions planned for the future, ISRO will move to cryogenic and semi-cryogenic rocket engines. More on these in the coming videos. Till then,